This is week 11, day 20. Not sure what happened to day 19. Anyway, missed a day or two here. So it's April Fool's Day. Okay? Fooled you. Thought it'd be 19. This week we are currently working on DHCP. Should be able to do it in a router and the multi-layered switch. We talked about it, did the labs, VLAN review, internet exams. Students are supposed to check and let me know if they have questions. Okay. First thing I'm going to do here, check. DHCP, dynamic host configuration. So, talked about servers and routers and switches. They all have processor, memory, motherboard, storage. We started out here, talked about routers, switches, firewalls, multi-layered switch. Firewall can act just like a router. Firewall can be like a switch. A multi-layer switch can be like a switch. A multi-layer switch can be like a firewall. And they all work. They're all some type of computing devices. We just have different ways of connecting to them. Okay. Now, here's our scenario that we've been working on. Oh, we talked about logging in to devices here. Okay. We have our VLANs, management VLAN, and we have our switch here divided into VLANs, and our multi-layer switch is divided into VLANs. And so this PC needs an address, so it sends a broadcast, and we can have DHCP set up in the multi-layered switch, DHCP services. So it looks for a DHCP server, sends a broadcast, DHCP services return it. Now, the confusing part would be if this PC, let's say it was on VLAN 10 here, that VLAN gets trunked up, so then it's tagged, and then it's VLAN 10 when it gets into here, so it knows this VLAN has an IP address, right? You assign that, excuse me, 172.17, then, whatever it was. So it has, that VLAN knows what network it's on, so it finds the right DHCP values. And then those values, then DHCP sends a unicast back, says, okay, I will be the service. Then it sends another broadcast to PC saying which DHCP server it's going to use, and then it gets the information from the DHCP server gets all of its addressing. Now, connected between here, we have a network, but routing won't forward broadcast. Now, what we wanted to do was we wanted to put a PC over here and get its DHCP from a router up above. And since routers won't forward broadcast, we had to put the helper address there. So, here we are, same scenario. We exclude addresses we don't need, and that would be like for printers, maybe servers, and your default routes. Inside the DHCP, we're going to assign a network and a mask, default gateway, DNS, and we can actually domain name and lease. Okay, there's some other things we can do. We can assign that in the DHCP pool. And then we have the two examples. We have the example here where it's going to use a helper to go get the address up above, and here all the VLANs will get their addresses from the multi-layered switch. So here's an example in a multi-layer switch. We exclude some addresses. We exclude the 30 and 40. Here's the DHCP for each of those. Okay, so we excluded those first 10 addresses for like servers or printers and for the default gateway, right? These are the default router to point at. And we create the pools. Okay, now we're to Wednesday. Routing topics, RIP, static, lab, DHCP topics, multi-layer switch, helper address, IP6, access list. We just start viewing access list. We reviewed cables. We have a rollover cable for counseling in. We have straight cables for normal work, and then we have a crossover cable where if you want to go, for example, directly from a router to a PC, a crossover cable pins 1, 2, 3, and 6 are crossed over. So the pins for receiving and sending are switched over. So when the PC sends a signal to the router, it gets switched over to the router. It goes from send to receive. Where that usually gets switched over is in a switch. Signal comes in the switch on pins 1 and 2, gets switched over and comes out on 3 and 6. If you're directly connected to a router is usually, there's a switch in between there. But we could skip the switch and use a crossover. They just happen to be red in our lab scenario, but they wouldn't have to be. You can make it out of any color. They just happen to be red in our lab. The rollovers are light blue and they're connected. I should go like this. They're light blue and they're connected to the PCs in the room, and all the rest of them, there's gray and blue and green, orange, yellow. They're all straight throughs. So here's our lab setup. People have a router, multi-layered switch, and a switch. And the things we should be able to manage now, things we've learned, we should be able to set up VLANs on the scenario. We should be able to do VLAN routing inside the multi-layered switch, and we should be able to do DHCP. In this case, in the multi-layer switch, and then we also did DHCP in the routers up here, and then we used a helper address here to send these computers here for their DHCP. Alright, so we did all that in one lab. Well, in one setup. It was in multiple labs where we did that work. Here's where we set up the DHCP here. It's for this network here. To get an address, come back. Actually, yeah, that's what we did. And then, what I did, leading up to next Monday, was I connected port 5 here, and then we did IP version 6. We got addresses using IP version 6. We got an address in the switch, and then we got addresses for the devices. And we did a couple different stages of doing that. Actually, we didn't quite get finished with that. We're still working on it. So, here, we're in week 12, day 22, April 8th. We reviewed a little bit DHCP. Should be able to do that in switch. We start talking about NAT topics. Network address translation. We go from one IP to another. And we didn't quite get to this. We'll cover this coming Wednesday. So, 2 basic steps. IP version 4 DHCP. You exclude your address, you make a pool, default gateway, DNS, what network we're going to pick it from. Then we also talked about network address translation. Or port address translation. It's kind of a specific form of network address translation. And in the case here, we're taking an inside address, or we're taking an address here and then matching it up with an address here for the other network. And in this case, we're taking multiple addresses here for PAT, and we're matching them up to one address and we keep track of them based on port numbers. We can match the address with a port number and keep track of that. Alright, and we're still working on NAT. Now we got a couple of things. We're going to talk a little bit about some IP addressing, and we did talk about being willing to change. We talked about growth mindset, drive, and a teacher's perspective, and how that all is related to learning and a lot more in being successful in life. Okay, let's get back to the networking. So down here we did an example where you have, like at your house, we have all these devices, and those addresses get translated to one public address to use out on the internet, and then they all come back to that public address. So in NAT we can also have a pool of addresses we pick from for NAT, or we can do it static. We can connect one address to another address. This could be the public address, this could be the inside address. Excuse me. Okay. Now, let me run through this briefly. Here, we took a look at, this is from Packet Tracer, Skills Integration, and they want you to subnet this into 2 networks, and it's already a /19. So here, I wrote out the addresses, and here's where a /19 would be. 8, 8, 16, 17, 18, 19 bits. So you got to leave that part of the address. Okay, the 128 gave us a 1 right there. So what we did was I borrowed a bit. So what we did here, we borrowed 1 bit, which will give us 2 options. I got them written out here. It could be, it's either that bit will be a 0, that'll be a 1. That'll give us 2 more networks. Okay. So the first network, I'll make it blue here, is this one when that bit's a 0, and then they want the last address, so then that is why all of those are 1s, and you can't have a 1 there because that would be a broadcast. Alright, so this part gets to be a little tricky. Like I said, you can't have a 1 there, so that would be a broadcast. So the 254 comes from, let me switch colors here. The 254 comes from those ones. It'd be 255 if that was a 1, but it's not because of the broadcast. That's 254. The 143, that comes from this group. So you got 128 plus these 1s, which is 15. And that's how we got 143. Well, it's not easy, but if you keep working at it, it will come around. So the next one we've got this for the network, and then all zeros, so that's 16 and 128. Okay, so that's how we get yeah, that'd be this one, 16 plus 128. That's how you get 144. And then the last address, we'd add these all together, so you got 128 over here. Yeah, 128 over, let's see here. You have 128 here, 16, 8, 4, 1, and 2 to get that address, and that's how we got to 159. Because it's the last address, so we had to add. Let me change colors here. We had to add this group together to get the 159, and this to get the 254. Alright, then we moved on. We looked at the routers. We had a floating route, so we turned this route off. We had a floating route in here, so the people in here, if they were going to go out here to ping this address, they would actually go this way. You go here, then go over here, and then go out, because this was out. So then these people would be going out their normal way. And then if we would have shut this one off, if we would have, and turned this one back on, then everything would have went out this router. So we have redundancy. We have two different ways, and we used to do that. Yeah. So to do that, we used a floating route. You know, we have a route with a higher administrative distance than RIP. RIP administrative distance is 120. And so I believe the students put these in. So I believe it was 150. Okay. We asked students to do the student performance, and we have a document here on metacognition. Do a little self-review. It takes probably 5 minutes. And then some ideas on learning. And there are a number of resources for that. And that is it.